In the screen you can see that a graph which is showing the power versus speed characteristics of wind turbine. The power curve of a wind turbine is a graph that indicates how large the electrical power output will be for the turbine at different speeds, different wind speeds. The graph shows a power curve for a typical Danish 600 kilowatt wind turbine. Power curves are found by field measurements, where an anemometer is placed on a mast reasonably close to the wind turbine, not on the turbine itself or too close to it, since the turbine rotor may create turbulence and make wind speed measurable unreliable. If the wind speed is not fluctuating too rapidly, then one may use these wind speed measurements from the anemometer and read the electrical power output from the wind turbine and plot the two values together in a graph like one, as you see. And you see with the wind speed increasing, as the wind speed increasing, power is also increasing, but up to a certain limit, and that is the rated speed, and after that power is not increasing with the wind speed. Okay. Now, while running any device or machine, it is very important to understand how to control it. Now here we will learn wind turbine control. The control system on a wind turbine is designed to firstly seek the highest efficiency of operation that maximize the coefficient of power, that is CP. Generally, there exists an optimum tip speed ratio, lambda, that maximizes CP. The sensitivity of CP to lambda motivates the closed loop control. The second most important point is to ensure safe operation under all wind conditions. Wind turbine control systems are typically divided into three functional elements. First, the control groups of wind turbines in a wind farm. Second, the supervising control of each individual wind turbine, and separate dedicated dynamic controllers for different wind turbine subsystems, each of which we will discuss separately. Let us understand what is the function of the wind farm controller. Its main function is power management. It can initiate and shut down the turbine operation, as well as coordinate the operation of numbers of wind turbines in response to environmental and operating conditions. Now let's know what are the functions of wind turbine supervisory controller. It manages the individual turbine operation. It manages the individual turbine operation, including power production, low wind shutdown, high wind shutdown, high load limits, and orderly startup and shutdown. It also provides control input to the dynamic controller, which we'll discuss later in the next slide. It also provides control input to the dynamic controller for RPM control, means revolution per minute. RPM means revolution per minute. So RPM control to maintain an optimum tip speed ratio. Why to maintain optimum tip speed ratio? Because on optimum tip speed ratio, the efficiency of power conversion depends. So optimum tip speed ratio and blade pitch control. So it maintains an optimum tip speed ratio and blade pitch control. Electrical torque control. This is another approach to control lambda through electrical torque control. Synchronous generators are used most commonly in large wind turbines. Synchronous machines are commonly used as generators, especially for large power systems such as turbine generators and hydroelectric generators in the grid power supply. The reactive power generated by a synchronous machine can be adjusted by controlling the magnitude of the rotor field current. Unloaded synchronous machines are also often installed in power systems solely for power factor correction or for control of reactive kVA flow. Now let's understand the strategies behind wind turbine operation. 4 strategic objectives to wind turbine operation systems are there. Firstly, this is to maximize energy production while keeping the operation within the speed and load constraints, because we cannot go beyond speed and load constraints. Secondly, to prevent the extreme loads and to minimize fatigue damage that can occur as a result of repeated bending caused by weight on the rotors and unsteady aerodynamic loads. Third is to provide acceptable power quality at the point of connection to the power grid. And last but not the least, to provide safe operation. 2 main types of wind turbines are horizontal axis wind turbine or HAWT and vertical axis wind turbine or VAWT. Let us first understand what is a horizontal axis wind turbine. A wind electric powered generating station uses 3 blades horizontal axis wind turbines HAWT. 3 blades design is more mechanically stable and can have less torque ripple. The blade length may be from 20 meters to 80 meters and usually of bright white colored so that any aircraft can view comfortably. A turbine with the blade of 80 meters may have a rating up to 8 megawatt. The height of large commercial turbine may be up to 70 meters to 120 meters and may be up to 160 meters in the extreme. The modern wind turbine systems use steel tubular supporting poles. The RPM of large wind turbines may be from 10 to 22. Such large turbine blades cannot achieve rotational speed more than that. As we told earlier, we use generating arrangement or gearbox to step up this slow speed to required high speed of the generator. Although there are some designs in which turbine rotor shaft directly couples the generator. As the rotational speed of the wind turbine varies with variation of wind pressure, the modern wind turbines use solid state converters to convert the generated electrical energy to a required voltage level and frequency to feed the electrical grids. No one can control the wind pressure on the blades by any means. It entirely depends on nature. The designers provide a protective systems to all large wind turbine which aligns the blade edge faces depending on the speed of the wind so that we can avoid breakage of the blades during high wind pressure. We call this technique the feathering. There is another type of wind turbine which uses vertically aligned rotating shaft. We call this turbine vertical axis wind turbines or VAWTs. As it has the vertical axis, it does not have to align itself with the wind, and hence using these turbines are most suitable where the direction of wind significantly varies. We can install the turbine when on the rooftop, even on the rooftop, since height of the turbine is much lesser than that of the HAWT. Another significant advantage of this type of shaft being vertical, we can extend it to the bottom level where we can couple a generator with the vertical shaft with the help of ground basis gearbox, which facilitates easier maintenance. In spite of so many advantages over HAWT, we does not use VAWT for bulk power generation, as the power output is quite less in VAWT as compared to HAWT.